So, we will continue our discussion on basic analysis in laboratory. So, today I will discuss about the calibration. So, basically when we will do experiment, particular experiment and there our aim is to find out some parameters, and for that we have to measure different parameters like temperature, like magnetic field, etc. So, there always we need to calibrate some instrument, or instrument is there, company has given the instrument, but we should understand the principle of that instrument. So, this calibration is a very common factor, okay, when you will do experiment in laboratory, and so we should have clear understanding of the calibration. So, this simple example we can take that if you take a scale for measuring length, right. So, in that scale this is a meter scale, centimeter scale. So, it has it has particular length, say is 1 meter or 50 centimeters length. Okay. So, in this, so how we know this? This is the length, it is 50 centimeters, or this is the length, it is 100 centimeters, means 1 meter. So, who has fabricated or made this scale? So, he has made, how he has made? So, that we have to understand. Basically, there is a standard scale, okay, international standard scale. So, there this 1 meter is defined. Now, if we want to make a scale, so we have to take help of this standard scale. Okay. So, what is the length of 1 meter? Now, that length you have to take from that standard one, international standard one, and now after getting that length, okay, now we have divided this total length into smaller division. Each division it may be 1 centimeter, or again in 1 centimeter again you subdivision you can make this 1 millimeter. So, that is easy task to do, because you know this the relation 1 meter equal to 100 centimeters. So, in that total length I have to make 100 division. So, each division length will be 1 centimeter. Again I know that 1 centimeter equal to 10 millimeter. So, again in each centimeter that division I have to divide it into 10 divisions. So, each division equally divide we have to make it. So, each division will be 1 millimeter. So, this is the basically you can make a scale, okay, but you have to calibrate it. So, how to calibrate and what is the meaning of this calibration? So, that with this example I am trying to say that. So, calibration means there is a standard length, international standard length of 1 meter. Okay. So, your scale whatever you are making, so that length, first you have to decide the length for 1 meter, or half of it may be 50 centimeter, and that length you have to get. So, how much length you will take, that length you have to take from this standard one. Okay. So, you have to compare with that one, and if it is comparable with that one, exactly similar, it has to be similar, same length. Okay. So, that's you are calibrating. If your scale length is not same as the standard one, there is a maybe there is a slight difference. So, then your scale is not correct one, or it is not calibrated one. Okay. So, this just one example I told you, but let us go for common device for measuring different parameters in our laboratory. So, this one is one parameter, most of the times one parameter we have to measure, that is temperature. Okay. So, for measuring temperature, so we use thermometer. Okay. Now, different kinds of thermometers are there. Okay. So, one common thermometer, you know, this is called this in doctor use this thermometer. Okay. So, for measuring our this fever. So, fever we define in terms of temperature. Okay. There is a normal temperature of human body. If the temperature is higher than that, then we tell is we have a fever, we have fever. So, that we check with the thermometer, right. So, thermometers, right. So, you have seen thermometers and you have used also. So, this generally is in doctor, this thermometer is the it is in Fahrenheit, this unit we use, that is Fahrenheit, and normally in our lab whatever we use, that is in centigrade scale. Okay. And another scale Kelvin is there, Roman scale is there, but Roman generally we do not use, but Kelvin we use, centigrade we use, also Fahrenheit we use. So, this scale is, you know, this not scale, this the thermometer. So, this thermometer is very simple one. How it works? We tell this mercury thermometer, that means in a glass tube we use this mercury. So, here whatever red we are seeing, red part, that is basically mercury, right. So, if I take a glass tube with small radius and very small radius and length is I think longer length, and if I put the mercury, okay, so this mercury position is say here. So, you can use any other liquid also, but this mercury is very sensitive to the temperature. In which way it is sensitive? So, here mercury, this one material we are using for measuring, for making thermometer because this mercury is very sensitive to the temperature. If you increase the temperature of the mercury, means if you heat it, then what happens? Its one property changes, this called thermal expansion. Okay. So, it's expand, it has properties, it expand with thermal energy when it gets thermal energy, or when its temperature is increased or decreased, its length changes, its volume basically changes. Since we have taken a fixed tube which is having a particular radius. So, this its area is cross sectional area is fixed. Okay. So, only lengthwise it can change lengthwise. So, in this case we are telling this it is okay, it is a linear, we are observing linear thermal expansion. Okay. Its length only getting changed, but actually its volume getting changed anyway. So, here its length will change when its temperature will decrease or increase. Okay. So, so this is the principle. So, this is the principle of thermal expansion of mercury. That's we are utilizing for fabricating a thermometer. Okay. And that mercury we have taken in a tube having a particular cross sectional area, and its length will change with temperature. Okay. So, so now that is fine. If we put in a thermal bath and change the temperature of the, if we heat it, so its temperature will increase, and mercury length, upper portion of the mercury, upper part of the mercury, okay, when its temperature is increased, then its upper end of the mercury it will go up. Okay. So, that means it's because of thermal expansion it is going up, and now task is that I have to scale it, I have to make division for temperature. So, it may be 1 degree step or 5 degree step, whatever. So, that I have to make a scale. So, that is basically scaling it. I have to make scale for temperature. So, you need, as I mentioned, that for meter scale you need the standard length of for a 1 meter, then you can make division. Okay. So, in this case also you need standard temperature, okay, no standard temperature. So, taking help of standard temperature we can make a scale. Okay, we can make scale. So, standard temperature, so this ice temperature. So, let us concentrate only the Celsius scale, and then there is a relation between Fahrenheit and this Kelvin, Roman. So, one can make it. So, let us just discuss the Celsius scale. So, ice temperature, that is standard one, international standard, that is taken as a 0 degree centigrade. Okay. And boiled water, the temperature of boiled water, so that temperature is taken as a 100 degree centigrade. Okay. So, this is the international standard. Okay. Now, so what I have to do? So, now I will put this mercury that mercury filled this tube, okay, in a bath having the ice. So, it is like this. Okay. So, then just wait for a minute, and when this mercury, this upper end will be stabilized, it will be at a particular, it will not change with time. So, this is stabilized. So, this I have to take as a 0, this I have to take as a 0, okay. And then I will put in a boiled water, okay. And then again I have to wait and see this, when this upper end of the mercury will be stabilized, means with time its length, it will not move up or down. So, it is stabilized. So, that I will take as a 100. Okay. So, this is 0 and this is 100. So, this now length is basically 100 degree centigrade. Now, I will make divisions, 100 divisions. So, each division will be 1 degree centigrade. So, information is that how I am making this thermometer, that is not the important for me. It is the important is that how we are calibrating, a system. Okay. It can be meter scale, it can be thermometer, it can be other thing, magnetic field, electric field, resistance, etc. So, there we have to compare with the international standard, it is defined, okay. And then we have to make scale making divided between these two upper and lower end. Okay. So, or this that is the total length will be this 100 degree centigrade here 100. So, we can divide equally into 100 division, and each division will give you will be the 1 degree centigrade. Okay. So, so this way, so this just we have I have on in lab frequently use this is the thermometer. It's the scale is 0 to 50 degree here degree centigrade. Okay. So, now question is how it is made here. This here I can see also minus 10 degree, and in picture here I am seeing also minus 20 degree. So, I think that if you know these two 0 and 100 and then you have division. Now, this is 20, this division 0 and this 20, 40, 60, 80, this 100. So, this length is 20. Okay. So, below here minus 20. So, I can take this equal this length downside, then it is below 0 degree. So, it will be minus 20. Okay. So, so for calibration basically if you get the length and what is the value of that length, and then from there you can extend it. It can be 120, 140. So, that way you can extend it. Okay. So, because you know already there which for 1 degree what is the length. So, then for 20 minus 20 or 120 plus 120. So, that you can extend the scale, but you have to calibrate with the standard. At least here in this case you need these two. Okay. That one is ice temperature 0 and another is boiled water temperature, that is 100. So, if you compare with this, if you compare with the standard these two temperature, and then basically you will find the length for this 100 degree temperature, and this other you can just calculate and divide the things and find out. Okay. So, you see this length is not this. Now, here whatever I am showing you, this quite big thermometer. Okay. It is the 50 degree centigrade. So, it is not like meter scale, this length is fixed for 50 degree centigrade. Okay. Here, so you can also make the same thermometer with the smaller size. Okay. With the smaller half of this size. Okay. Or you can make it as a double whatever the size is, you can make it double size. Okay. Double length. Okay. So, in this case this length is not fixed. Okay. So, for each thermometer, if its that tube, that hole, okay, its diameter or cross section are different, then this length will be different for this 100 degree centigrade. Okay. So, depending on the cross section, if cross section is higher, then its for same 100 degree centigrade temperature length will be smaller, because as I mentioned that it depends on the its expansion is basically volume expansion. So, if cross section area if it is fixed, then lengthwise it will expand. Okay. So, for different thermometer basically these cross section are different. So, length will be different. Okay. So, so for each temperature one has to calibrate it. Now, I cannot take it is now calibrated. Now, this I cannot take for calibrating the new another thermometer which I am fabricating, and its cross section may not be same as this one. Okay. So, taking the length as a calibrated one, so that is not correct for this case. Okay. So, with that we have to understand, because here length is not important, important is the volume expansion. So, what will be the length for 100 degree or 50 degree? So, that will depend on the cross section of these holes. Okay. So, this is the one example of calibration. Why I am discussing? So, when we are teaching in lab, so there we have seen that when we are doing experiments, so there is one experiment is basically is the assemble of many small components. Okay. So, for what is the aim of the experiment? So, to calculate, to find out some parameter. Okay. That parameter is basically define the some properties of this say material, and then for that we have to do different measurement, and there this temperature measurement is there. So, as I told, this temperature measurement, it can be for you can use for this commercial thermometer, as this is the commercial thermometer. Okay. Or you do not have option to put this thermometer in that geometry, experimental geometry. So, you may need to use other thermometer. Okay. So, other thermometer, you know, this another thermometer we use in lab, that is thermocouple. Okay. Thermocouple. So, thermocouple basically what is thermocouple? These two dissimilar metal, if you make two dissimilar metal, if you make junction. So, this is the wire of wire A and this wire B. So, is wire A is made of some metal, so maybe copper, and this wire B is made of some other material. So, this it has to be dissimilar material. So, if you take these two dissimilar material and then this if you make junction here. Okay. So, this wire, just twist it here. Okay. So, then this is one junction and other junction is this one, and this if these two junctions are kept at different temperature. So, there is a EMF, thermo EMF produced, generated in this case. So, basically there will be thermo EMF, or this there will be voltage difference between these two junction, that we could call thermal EMF or thermo EMF. And if you can measure this thermo EMF if you put this 1 voltmeter here. Okay. So, this the you see this is the principle of thermocouple. So, here thermo EMF will be generated if temperature difference between two junctions is there. Okay. So, this property will be used for making the thermometer. Okay. So, this one junction you have to keep at say some temperature here, or this we are telling cold junction, and other one will be at hot junction. Okay. So, company basically they will give you this ready made thermocouple this base thermometer, and we will use it because just there will be meter, and there it will show what is the temperature of your sample, but but sometimes you can make yourself this type of thermometer. I will show you. Just take two types of wire. This is one wire, you see. This is one wire, okay. This is one wire, just I have taken from my lab. This is one wire, and you take another wire, another type of wire. This made of, here is written I think tungsten, okay. There are different. So, again another things you have to consider that your thermometer or any whatever measuring instrument, it has to be sensitive. So, there is a combination of wire, chromel, alumel, then I think tungsten and this other tungsten and this other copper wire may be, okay. So, this copper wire may be, yes. So, there is a combination, it is a depend, one has to find out. So, if you take these two type of dissimilar materials, so your thermometer will be sensitive, means for a small change of temperature, okay, your EMF, thermal EMF or thermo EMF, this will be, that change will be higher, okay. So, that way, so this people have find out. So, that has come from research, find out the combination of the dissimilar metal. So, just take two dissimilar metal and then you make it. So, one is copper wire, have taken another tungsten, so just make it. This will be just one junction, this will be just one junction, okay. Okay. So, you keep the junction at a low temperature, So, gel you can use as a this cold junction, you can put in ice, okay, and then you have to make other end. So, that other end we have to put in say boiled water, okay. Now, for or unknown temperature you will put. So, so then you have to measure the voltage in between, you have to connect voltmeter, you will measure the voltage. So, that is the EMF, thermo EMF we are telling. So, now other end, if you put, this is in ice and other end is in near to your sample. So, we will get the thermo EMF or voltage in our voltmeter. So, you will take this reading voltmeter, but this voltmeter whatever reading it is not giving temperature, it is giving voltage, okay. But this voltage has relation with the temperature difference between this cold junction and your hot junction, where you which you put at the near your sample. So, that temperature whatever the temperature. So, this is 0 and this is some temperature say T. So, because of this temperature difference T, you are getting some voltage V, okay. So, this is the relation between these two, this if temperature is change of this hot junction, then you will get the some voltage. So, we are measuring voltage, but I want to know the temperature of this end. So, how to know? So, to know that one you need to do calibration, okay. So, before you use this thermocouple for measuring temperature, I have to calibrate, okay. So, then it is easy, just you put it at known temperature, say ice temperature, and this other end you are putting this say boiled water, okay, boiled water, then you know this temperature difference is 100 degree centigrade, okay. So, now for 100 degree centigrade, what is the voltage you are getting, okay. So, if it is relation is linear, then if this is linear, relation is linear, then you can find out directly, you can find out this this from relation between the voltage and the temperature, and calibration factor generally one can find out. So, then what we tell, this is the voltage V for temperature 100 degree. Okay. So, for 1 degree what will be the change of voltage. Okay. So, for 1 degree, so we have to divide by 100 T, you have to divide by T. So, V by T, so that equal to some C, let us write C. So, that is the calibration factor. Now, whenever you will get voltage, okay, so for 1 degree what is the voltage you are getting, so that you know. Now, whatever the voltage you are getting, so this actually I have to tell calibration factor, whatever tell, just it has to be opposite. So, for some voltage V we are get that temperature difference is 100. So, this temperature T divided by V, that will be the for 1 unit voltage what is the temperature. Okay. Now, whatever voltage you will get for unknown temperature, so if you multiply with this calibration factor, then you will, so that voltage will be converted into the temperature. Okay. So, earlier whatever I told, then you have to basically in that case you have to divide it. Okay. So, if it is linear, so but its relation is not linear, so it is something is slightly different, then linear is non-linear. So, in that case basically you have to take it is not for only one temperature difference. So, you have to take 2 temperature difference or 3 temperature difference. Okay. Generally we take 2 temperature difference. So, you have to use another temperature, known temperature. One can be boiled water, another can be other standard temperature you have to take, or one can take boiled water, not boiled water, hot water, but you take help of standard thermometer, mercury thermometer, and this you keep this water temperature at say 70 degree and take the voltage, you keep the temperature at 100 degree, take the voltage. So, so because in this case you are using the standard thermometer which is already calibrated and taking help of this thermometer. So, you are calibrating your thermocouple. Okay. So, this way one has to calibrate and this is very important, because if it is commercially available, you have to understand how it works. If it is you have to make it, because experimental geometry sometimes it does not allow the standard thermometer. Okay. So, you have to fabricate yourself, and when you are going to fabricate, you should have clear idea. Okay. So, here generally commercial also thermocouple is used, but it is not thermocouple, it is not calibrated one. So, this commercially available thermocouple, so just it was in my lab. So, here inside these 2 wires are there, okay. 2 dissimilar wires are there. They are basically isolated one. Here you see these 2. So, I do not know whether I can show you this. No. Here I think the other end is, you see it's no, probably. Can you see? Yes, I think you see 2 holes are there, these 2 you see is 2 holes are there. Yes. Okay. So, 2 wires, 2 types of dissimilar wires you see here, you know. So, they are nicely, they have this they are isolated, but they have made nicely with some covers. So, there are some reasons why they have used this type of. So, for you see there are some particular geometry, experimental geometry, where you have to put it, and then there will be heat generation. So, that heat should transmit to the other place, okay. And so, that way this type of thermocouple, this covering with covering will be helpful for that geometry. So, these the commercial thermocouple is available. Now, this type of thermocouple we use in our lab, but in this case again it is not calibrated one. You have to calibrate. So, you have to make these two junction, here one junction and other end here one junction. In between you should have. So, basically you have to then you have to use your voltmeter. So, one junction we made it okay, junction, and other junction basically taking the third wire. Okay. So, if you put third wire, there will not be change, there is a theory. So, you use voltmeter to measure the EMF. Okay. So, before using that one, as I told, once you have to keep at different temperature at this, and what will be the voltage for this known temperature, and you have to calibrate first, and then you can use it for measuring unknown temperature. Okay. So, this the calibration of the instrument. And another one is not magnetic the thermometer, but this magnet, electromagnet. So, how to again this, there are two coils placed, okay, and these pole pieces are there. Now, if you pass current through these coils, and then there will be magnetic field between these two pole pieces. Okay. Again, so what is the relation between the current and magnetic field? So, to know that one, you have to measure the magnetic field here. So, again you have to take some standard, is called Gauss meter or Tesla meter, okay, some standard meter which can measure the magnetic field. So, you have to place that meter here, and that will give you the magnetic field for different current. Okay. So, so you have to calibrate here. What you are calibrating? You are calibrating this magnet for a particular distance between the pole pieces. Okay. So, in that case you are varying the current and measuring the magnetic field using some standard Gauss meter or Tesla meter, okay, and you are plotting this in this graph, and here it looks very linear. So, this way also we calibrate. So, it is not just 1 or 2, 3 reading, there are many readings, and then we plot. It is here it is showing linear relation. So, if you plot, then next time you do not need this Tesla meter. So, because this magnet is calibrated, means if I know the temperature, know the current, then from here I can tell what is the magnetic field. So, this frequently in lab, frequently this type of calibration we have to do, and we have to use, because in experimental geometry you will not be able to put the Tesla meter there during the experiment. So, only you can change the current of this, and in that field you have put sample. So, there you have no place to put this Tesla meter or Gauss meter. Okay. So, because that is the restriction of the geometry of the experiment, and in that case you have only option to calibrate this magnet first, and then you remove this Tesla meter and you start your experiment. Then whenever you are changing the current, and but you are not interested about the current, you are interested for that current what is the magnetic field. So, from this curve you will get the magnetic field. So, I just discuss few examples, but there are many examples, and in laboratory you will see this we need to calibrate. This is very one important things one should know. So, that is why I separately I discuss this calibration of the instrument, because otherwise this will be missing when we will do a particular experiment, and there are many components, and will not be emphasized, will not be able to emphasize on this calibration things, but it is very important. Okay. So, I think this this about the calibration I will stop discussion. Thank you very much.